So next up is Aleksi. Shall we ask you if you're staying for sauna?
After I've presented.
Okay, well, there may not be any tickets left.
So, peering at the speed of RFC8950. This is based on a presentation I've been giving at the various events already in Northern Europe, but it's slightly modified for local flavor. So what is it about? So RFC8950 specifies a way to announce IPv4 routes over IPv6 next hops. So the title peering at the speed of RFC8950 is like a very sexy title, and RFC8950 is the future, is sort of the gist behind the title. But the point is that RFC8950 allows networks to eliminate IPv4 address space from link networks, from the backbone. But we are now exploring the opportunity to also eliminate IPv4 address space from IXP peering LANs. So TREX announced and started a new IXP in Turku, the third biggest metro area in Finland, this winter. And we are doing that IXP, RFC8950 only. So it will be possible to exchange IPv4 traffic in Turku, but people won't have IPv4 addresses on the Turku exchange. And that's what it's all about. So the routers will still need to have one IPv4 address somewhere on some interface, usually the loopback interface, so that they can send ICMP errors, and they usually have a need for an IPv4 address for other reasons as well. But links and now the IX connection don't necessarily need an IPv4 address anymore. And why? So we already did have a bit of IPv4 address space earmarked for the Turku exchange point, but renumbering to a bigger network is painful. And to get to a /24, which is the usual comfortable size for an IXP subnet, would require already renumbering twice. Examples of what the pain looks like is France IX announced they were renumbering to new addresses 2019 in the winter, and 2021 in the fall, they finally turned or got rid of the last old IPv4 address on the subnet. Thanks to Radu Adrian from France IX for this information. All the big IXPs in Europe have already renumbered several times. And Links, I guess, was possibly the first one to renumber in 1997. DECIX has managed to go a slightly different route. They renumbered once, but they chose an address space where they had lots of space behind it. So after the one renumbering, they have changed their net mask. Was it twice or 3 times? Twice. Thank you, DECIX. So that's less painful, but if you ask Daniel, was it painless? It wasn't, because still, if people have the wrong net mask on the subnet, funny things happen, especially if you also use the route server there. So the alternative to all this pain would be to renumber one final time. And I say renumber in quotes because it's not real renumbering, because everyone already has IPv6 sessions on the peering LAN. So all they really need to do is turn up a new address family on the existing IPv6 peering session and add a certain configuration line that makes use of the RFC8950. So TREX Turku is not the only one who is testing this. So NIX in Prague, in Czechia, has a special Phoenix subnet for their, well, let's say local ISPs, but it's basically high security peering community in Prague, where the operators take security and DDoS and stuff like that seriously. So it's a smaller group than the whole peering LAN. And they are using that, and in May they reported they had 12 members, 24 BGP sessions using, and 214 prefixes announced using RFC8950. Also here in Tampere, our older exchange point, we have set up a third route server that supports RFC8950, and it's pre-configured so that everyone that's already using one of the or the older route servers at TREX Tampere already have a session on the waiting on the third one. So it's basically, you look at the IPv6 addresses of the existing route servers at one, and that's the new RFC8950 route server. TREX's own router is peering already with that route server, and the AS112 Anycast is also already peering. So there should be a few different routes coming from that route server if you want to test it out. Right. So what about new IXPs like Turku? So if we start with the IPv4 subnet, it'll be later difficult to get people to stop using it. Yanking it out is going to be just as difficult as renumbering. So what we are trying to do in Turku is we are trying the approach that we never give it an IPv4 subnet in the first place. Most of our members run platforms that have mature support for the technology, so in theory, there shouldn't be any problems. So Turku is a new IXP. We are planning to have 2 sites, but only the first site at Telia Linnankatu is operational now. We are also trying to get it listed, the facilities where we are located, listed on PeeringDB so that we can get you members clicking which sites you are at so that we can have PeeringDB presence for the new IXP as well. But so far there hasn't been any luck with that. So EuroIX is the association of internet exchange points in Europe, and Physics, TechX, TREX, NetNod, all our sponsors here are members of EuroIX. I think all or most of our sponsors are also patrons of EuroIX. So they have a working group established a couple of years ago who are working, and I think I've already said this at an earlier nog.fi meeting, but we're working there in the working group to test, map out the challenges of the new technology, and now that we've started seeing more and more hardware implementations and not just open source software implementations, we've also started to go through interoperability issues. And Daniel, can you stand up? So TechX has actually hired an MSc student to do all the testing. So they are putting their money where the mouth is. Give them a big hand. And of course, there are members from all sorts of our organizations, including the organizations that write the software like NetDef and NICZZ. NICZZ writes BERT routing daemon, and NetDef is behind FRR, which is the Quagga spin-off that seems to be doing better than original Quagga right now. So there's also a GitHub with the working group, and I'll come back to that if I have time. But there's lots of examples there for different platforms, and you can also look up, there's a table that lists all the different platforms and which software version supports it, or is it on the roadmap if it's not supported yet, or stuff like that. And we are accepting, if you have some platform that we don't know about yet, then we accept pull requests, so you can send updates to our table and our config examples and so on, and we're happy to accept them. And we also got a mailing list and a Mattermost chat channel if you want to take part in the work more seriously. So come talk to me if you want to join the mailing list or the Mattermost chat. So some challenges. So Juniper and Nokia are examples of platforms where the support is pretty good. A lot of the testing with real hardware has been done on these two platforms. But for example, in Turku, we already know of two challenges. So we have one potential member, one operator in Turku who wants to join, who is running MikroTik. But MikroTik doesn't really support this yet. So the kernel and the user interface has supported this. You can make static routes for IPv4 routes with IPv6 next hops, for example, using the MikroTik configuration interface. But the BGP implementation doesn't support the BGP path attributes required to make the route announcements. And last I remember, they don't have it on their roadmap yet. Huawei, another big or growing hardware vendor who we have a few members of that want to join Turku, has said they support it, but we haven't found or received any examples of how to configure it. So, so we don't know if it really supports it. A few other points, important points, is that the best current practice for iBGP is to use NextHop self, but with RFC8950, using that becomes more important, because if your iBGP mesh has routers that don't support the extension, then they will be confused by the routes they receive from other routers within your AES number that do support it. So, and if you don't know what that, if you don't understand what that means, talk to me later at dinner or sauna, and I'll explain more grassroots details what this means. Also, ISAMP unreachables. So if you trace route through a BGP connection based on this tech, the router that doesn't have an IPv4 address anymore will, of course, then try to use some other address on the router to send the ICMP unreachable, so the trace route knows which router the packet passed. Most vendors say that in this case they should be using the loopback interface. But even though they say that we've found in lab tests that this is not true, they are using, in some cases, a completely random interface that is not related to the path at all. So the logical idea is the ingress path or egress path interface IPs, but they might be using, you know, some completely different interface instead. And well, so we've been working at EuroIX for a couple of years and mapping all these different, how different vendors behave and so on. And we've been giving feedback to the vendors so that the vendors know to fix the bugs, and eventually they, by the time anyone in Finland will start seriously adopting the technology, hopefully all the bugs will be fixed, at least on their platform. And here's an example of how to connect to the Turku exchange. So this particular example comes from our own Juniper router. So, and it's a bit edited to look pretty. But which one's the laser? That's the laser. So you need to enable family IPv4, because otherwise it won't forward IPv4 traffic on the interface at all. But you do not need to add an address, because it's using this to do the forwarding. And of course, you can still add filters and stuff in the IPv4 section. If you do add some address here, then that will, on Juniper, typically show up in the trace routes. But otherwise, it could be some other interface. So if you want trace routes to show that it went through the TREX subnet, for example, then you can choose some random free IP address, usually addresses ending in .0 or .255, are free, so you can just use something like that on the interface, and then traceroute will show that, and then you can give it a reverse mapping that will, tell people what's going on. And then the BGP neighbor config, this is for the peer group, so it'll be shared by all members of the peer group. One interesting thing about the Juniper implementation is that you have to filter both IPv4 and IPv6 routes using the same filter. So these get a bit longer than if it was just one address family. On some other vendors, you can configure the filters in the family area, so you can have a separate filter for IPv4 and another filter for IPv6 routes. And the important thing is, first of all, to enable family inet again in the BGP as well, and then this extended next hop is what turns the RFC8950 functionality on. And here's an example of an existing route with one of our members that is connected to both Tampere and Turku exchanges. So the last one is our route through our transit, and the second last one is the route over the Tampere peering LAN using legacy BGP. And then the two first ones are examples of the same route being exchanged in Turku using RFC8950. So there you have it. Suddenly an IPv4 route has an IPv6 next hop. And what that of course means is then the router won't be doing ARP for the next hop. It'll be doing IPv6 neighbor discovery to figure out where to forward the IPv4 packets, as per the RFC. So here's the GitHub I mentioned. So in the examples folder is most of the interesting stuff. So this is the table I mentioned. Here are the different vendors and platforms that we have that we know about. And for example, Arista, the first one here, this software version has good support, but the notes say that it has had the support already for a while. For Cisco, two of the platforms either don't support or we don't really know, but iOS XR has proper support since 7.3.3. Open source, well, actually, fun fact, Bird, the reason to create Bird 2 is because the architecture of Bird 1 could never support this thing. So when people started asking Bird to start supporting RFC8950 or its predecessor RFC5549, they started work on Bird 2 so that they could support it. And Bird 3 is pretty identical to Bird 2 when it comes to this feature. Junos has had good support since 17, which is a long time ago, but we found that basically the newest Junos 23.4 is the first one where we don't see certain interoperability challenges. I can talk about that later at the sauna if somebody's really interested. Microsoft, as I said, does not support, and so on. And maybe I should show an example. So here's Nokia SROS config example. So this is what it sort of looks like. And so that's a filter, what the filter looks like for it. And it's an interface. Maybe I should have looked at this before. So here's, yes. So this is the magic word to get Nokia SROS to do the right thing with the next hops. And actually here are listed the most important things in the config as well. And then here are some examples, show routes and trace route. Yeah, that's the actual show route. And things like that. Not all of these are complete yet. The guy from DKIX is working on these as well, but we, as I said, are also accepting pull requests from from anyone that if it looks right. And I guess I just went over time. So no questions. Get me at dinner or the sauna, and we can talk more about this if you want. No
Thank you, Aleksi. We do actually have a couple of minutes till the next talk is due if somebody has a quick question.
Well, yeah, quick questions.
Question. No, don't be too extravagant.
Aleksi, did you mention I'm Lassie from Telia?
Mm-hmm. There we are.
Where is the new exchange in Turku, and what is the data center that you can't get in PyongDB?
It's the Telia Linnankatu. It's a high security location, so I suspect that is why there's reluctance to get it listed. And then the other location that we have already decided to go and where we have already agreements for a Lambda so that we can get it connected is Kupittaa. So it's a big area next to one of the railway stations, which houses a hospital campus, a high-tech campus, a university campus, and they're all interconnected through underground shared car parks and stuff. So we need to pick some place where to put our stuff there, and then everyone there can easily connect. For example, the Finnish University Network has mentioned that they would be interested to connect, but they want to connect where their router is, which I understand is at Kupittaa. So.
Okay, thank you.